Hello, it's me again. Thank you for joining Practicalli with me, John Stevenson. And today we're going to do some more coding challenges. You get those fingers working and the brain cells working. And so before we start, let's just remind you how to get in touch. All the videos, all the work I've been doing so far with Practicalli is on the website, so practicalli.github.io, and all the broadcasts. I've been doing a few updates in the books. I'm going to start doing some more stuff on the data science book in the end of November. And you can get in touch with me with these methods. I do encourage you to use Clojure and Zulip. It's a very nice way of finding the right discussions to get involved in and hiding the rest of the discussions you don't want to, you're not so interested in. And if you want to support me, then there's these channels as well. I think we're over 800 people subscribed to the YouTube channel, so thank you very much for everybody who's done that. And again, thank you to Clojurists together for the continued support to give me more time to work on these things. So some of the things I've done this week, I've done sort of an install guide and a user guide for Clojure and NeoVim. So Clojure is a really nice Clojure environment, Clojure development environment for Vim, and so I'm using NeoVim with that. And it's got a pretty nice development experience as well. It's pretty it's fast and it's relatively simple, but it does all the important things you want to do with Clojure. And also, it's a good opportunity to learn NeoVim and learn Vim a little bit more as well. And also, I've been doing I did project graphs deps to my project. My Clojure deps.edn configuration. So you can create nice little diagrams from all your dependencies. So you can see just how many dependencies you've got, and you can see the versions they are in, and you can also include the size of those libraries as well. So it just helps you understand what you've actually put into the project. So that's all there in there now. But today we're going to talk about exorcism, and we're going to do some Clojure. So I've joined the Clojure track. So you basically just go into exorcism.io, register for a free account, and then select the language tracks you want. So I'm doing Clojure and Emacs Lisp, although I haven't actually done any of those yet. But there's lots of other ones you can try as well. But I'm going to focus on Clojure. So I've done a few of these. I haven't done that many yet, but I think we've covered some of these in other earlier videos. And so we're going to cover Bob, which says it's easy. Well, it depends how well you understand the requirements as to how easy it actually is. I think that was the biggest challenge for me. So we're going to have a look at Bob. So if you've not used exorcism before, it gives you instructions on how to actually do it. It gives you need the exorcism tool, and you can download the project, which is a Leiningen project at the moment. This was set up quite a while ago, I think before Clojure CLI tools came out. And then they give you, when you download hello Caesar, when you download the exercise, so it's specifying here that we want the Clojure version of this exercise. It's going to download like a shell source code file, and you're going to get a test suite as well with all these tests in here. And so you have to make all the tests pass. And then you can just submit the solution, which is a quick sneak peek look. Regex. Oh, I'll explain all those as we go along. What else? And so the code, I put a link in the chat. So the code is here, and we got to walk through. So it's a project.clj file, but it's literally just a, oops, it's literally just got a dependency on Clojure. So you could quite easily just drop in a deps.edn file. Let's do that. I was going to do that. I said I was going to do that, didn't I? Yes. This is my project. Let's make that bigger again. Whee! There we go. So if I go to the root of Bob, so if you clone my repository, then there's all the different projects in here as separate folders. So each of these folders is a self-contained project. So we go and select Bob and project.clj, that's the lining configuration. And if we create a new file at the same level, go to deps.edn file, boom. And then we might be able to get away with, where's my curly brackets gone? I mean, that's the world's simplest deps.edn file. It can be enough because it's getting merged into all the other files. So if you look at, we go to did I close that? Oh no, I didn't know. If you look at the Practicalli Clojure deps.edn project, so that this project deps file I've just created is merged into the Clojure deps kind of user level and the CLI tools. And if I go back to 3, we go and have a look at the deps.edn file. You can see that we're actually including source in here already, and the version of Clojure. So that would be kept, and then any additional things is merged into from the project deps.edn file. And if that doesn't replace anything, then you just use the ones from Clojure.deps.edn. But I'm going to do a little hack. So we've got, so in the Clojure, and so in the user level deps.edn file, I've got path source. If I grab that, oops, wrong one. I'm going to do path source. I'm going to do. I'm going to be sneaky and add test in there. So that way the cider runner will be able to find the test code. I'm using Emacs and cider, so this tells cider that there's also code in the test folder. And if we have a look at the structure of the project, so Bob we've got the deps.edn file in there now, and we've got source test directories. So without adding the test to the source, it wouldn't be able to find bob.test. Just need to add that for the cider built-in test runner. So if we go to our Bob file, go to source, Bob. So Bob's got the finished solution, which hopefully should work. We've actually got a running REPL there, so I'm going to kill that. And we're just going to make sure that deps.edn file is good enough to run this. Yeah, so now it's running. You see the command line at the bottom, it's running Clojure deps. because I've got Spacemacs set up to run. If there's a choice between deps.edn and project.clj, it'll run deps.edn. It's just a setting in my in the way that Cider is included. And you can also set that as in the dir locals.l file. Okay, let's so that's all evaluating. If I do space PA, I can switch to the tests. Let's just check that all the tests are running. Yay, that's working. So I can use Liningen, which is the original configuration that comes with exorcism.io, or I can use Clojure CLI. And I don't really need to add anything else in here for this, because I'm not going to deploy this anywhere. And I can use the tools from the user level deps.edn configuration. So I don't have to add them here. If I add them here, then if the libraries update or change, then it just means I have to come back and edit this file as well. Whereas if it's all just kept in the user level config, then if it's updated once, it's updated for all the projects. If I was going to ship it to Clojure CLI, Clojure CI server like Circle CI, then obviously I need to include any particular aliases that needed to run tests, and I kind of make test a separate alias. But because I'm not going to package this up into a jar file, then this is a nice quick hack. Let's put that down as a quick smiley face. There we go. Oops. Oh. Let's get on with the coding. Okay. So we've got the finished result, but how did we get there? You saw that all the tests run, so let's go through the design journal, and this will step us through how we actually got to my kind of preferred solution. So design journal is just really a kind of record of how I've figured out how to get to the solution. So you've got the kind of design story behind the solution, which is very useful to help you learn Clojure. And what I've done is just put this comment block in. I've actually got a rich comment snippet, which just creates a comment for me. It also includes this CLJ. I'm using CLJ Condo as a linter, and as like almost like a pair programming buddy that tells me if I do things that aren't quite right, or if I've got syntax errors, or if things are less than idiomatic. So here I'm using Clojure string, but I didn't do a require, so it's given me a subtle hint that I should do that in the finished code. Because I might be defining several versions of the function, of functions with the same name, then I'm getting it to I'm asking it to ignore these redefined vars. So if I have a function Bob, it's not going to complain when I do the same again. Bob. But if I remove this little bit of metadata, then it would complain. Oh, look, it's complaining. See, that's quick. Whee. Yeah, so now it's complaining. It's they're the same. Oh. So that's a useful little thing to add. And I put all the design journal stuff in a comment so that I don't accidentally just evaluate this buffer. Because if I evaluate the buffer here with everything else in the comment, oops. It still needs to be good code, but it's not going to add anything into the running REPL by accident. I have to actually go in and evaluate things manually there. Oh, I've got a missing thing. I've got a question in the chat. What is powering the awesome directory tree in the left sidebar? So this is TreeMax. It comes with standard bar. It comes in as a standard with Spacemax. So it's just space. I just use space project T to toggle and untoggle that, and it's quite nice. You can add and remove projects from there as well. So remove the project, so you can keep it nice and tidy. Oh, there's my keyboard stuff there. I don't need that in there. Boom, 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 boom. Boom. Let's remove that as well. So you can use it. There's a little. There is a menu thing in there as well. You can also use it with keys as well. So yeah, I don't really use the mouse that much with Emacs, but occasionally I do. Let's remove that project. There we go. So it's quite useful, especially for demos and showing you like project structure and which file I'm on. But most of the time I just hide it. Ooh. Let's see. Right, let's go through the design. So if we go back to Exorcism for just a moment. So here it's got a few instructions. So it's saying that so Bob is a ladastical teenager. I think I had to actually look at what that meant. But essentially, it's just very basic answers to questions. So if you ask him a question, he's just going to say sure. If you shout at him, he's going to say whoa, chill out. And if you ask him a question, or if you yell a question at him, and then if you actually just send him a message, but you don't actually say anything, so it's a meaningless message. And then for everything else, he's just going to say whatever. So it's the basics of like a chatbot or a text adventure game. It's kind of like that kind of basic response. You get a string, you pass the string in some way, and then you decide how to respond. And then the test suite. But one thing I did notice is that like this doesn't give you all the answers. Just like working in industry, you don't always get the full requirements. And looking at the test suite, so you do need to go through and so understand the test suite a little bit as well. So we'll do that. I'm just going to make that a little bit bigger. Oops, that's smaller. There we go. So we're going to ask Bob a question. How do we know if we're sending Bob a string? How does Bob know that string is a question? Well, he's answering with sure. So if we go to the tests under if we go to the tests. So this goes to Bob_test, and I'm just going to search. I'm going to do like a smart search for sure, and so we can see all the different ways, all the different kind of strings that have been used for sure. So they're all kind of ending in question mark. Some of them have gibberish in there as well, but that's still a question. So we're not really testing to see whether something's gibberish. If it's got characters in and a question mark, then that's good. If we've just got smiley face, I guess that's asking if Bob if he's happy. Yeah. So the thing you've got in common is that they're they've all got question marks at the end. That one's interesting because it's got a question mark, but it's not at the end of the string, but it is at the end of the characters in the string. So if we can do last on this is a question, so that's going to get the question mark. It's going to pull out the question mark because last is treating the string as a sequence of characters. It's not a string isn't an official sequence in Clojure, but when you use a lot of the Clojure core functions, it just treats it as a sequence of characters. So if we just evaluate last, then it's returning the character, which is the backslash denotes there's going to be a character, and the question mark is the value of that character. And so then we're just using equals as a comparison. We don't use equals as assignment, we use binding for that. So we can use equals as a comparator, say, does the character last? So that's going to work for most of the tests. Although if we've got not sure what I did with it. Oh yeah, so it doesn't matter where the excuse me. Bit of a cough this morning. Yeah, so it doesn't matter exactly where it is at the end, still works. But if it's not, oops. Come on, what are you doing? But if it's not the last character, so in this case we've got white space as the last character, so that kind of falls down a bit. But there's some nice functions in Clojure.string for dealing with strings. And yes, we should really include Clojure.string as a require. Let's do that in here. Require Clojure.string. And yes, so now CLJ Condo is happy again. So if we trim the string, then it's going to get rid of this white space, and it's going to, yeah, then I can use this simple form to check that it's a question. So that should be good enough to start with, I think. So that's the asking Bob a question. So what I'm going to do is walk through, oops, hang on a second. So what we're going to do is create all the kind of rules, model all the rules, and then put them together at the end to decide how to respond. So I'm yelling at Bob, and if we're yelling at Bob, then he's going to respond, "Whoa, chill out." So let's go back to the tests and search for, oops, wrong one. We search for "whoa, chill out," then you can see that it's got uppercase characters in, yeah, they're all uppercase characters. Some of these have got numbers in as well. And then some of them have got all sorts of weird zombies are coming. So this has got characters and uppercase, but they've all got uppercase characters as part of that, and they don't have any lowercase characters. Unfortunately, there's no function to check whether a string is uppercase or lowercase or capital letters, but we can write a simple comparison. So if we just convert a string to uppercase, then we always get the uppercase version. But if it's already uppercase, then it's not going to change, and so we can compare it with the original So when we compare watch out all in uppercase with watch out uppercase, then it's going to be the same. And if we compare it with the lowercase version, then obviously that's going to be false. Oh, actually, I should have did that the wrong way around, didn't I? Oops. Did that the wrong way around. It's that way. Whee. Oh no, it should be both, shouldn't it? It should be both, yes. There we go. Yeah, so if we uppercase watch out, then obviously it's not the same as it used to be. So that's a very simplistic way, but there's a problem if there's just numbers. So there is one test that just has numbers in, and if you uppercase that, then it's going to be the same because you can't uppercase numbers. So this gives a false positive in one of the tests. It makes it seem like the test is shouting when it shouldn't be. If we go back to the test and do so show like string 1. Yeah, there you go. So the string 1, 2, 3 should actually return whatever. But if it's got capital letters in as well as numbers, then it should be whoa, chill out. So that's one that caught me out initially. Oops. I do have a bit of a coffee this morning. Okay, yeah. So how do we get around this? Well, if we redefine the rule a little bit and say there should be uppercase characters and no lowercase characters. So I wrote a little function just to help me test out different strings without having to copy the expressions over and over again. So here, if we do refined on a phrase, so let's just debug this. We call shouting with hello. Then so we're passing in hello into the function, and it's going to return nil from this refined because it's looking for characters A to Z that are lowercase, which there aren't any, and then we invert it by passing it to not, and then we get true. So we can see that this is shouting because there aren't any lowercase characters. Whereas if we do it with this, then we can see that where H is not matched, but E is, and so that's false. So this is getting rid, and so this is trying to find out if there are any lowercase characters. And another way to do that is there's also another way of expressing that, which is using the this Unicode regular expressions, which is like a LI. I find that a little bit more cryptic to understand this. I think this pattern is something that I'm more used to. Somebody asking why not AZ. Yes, so I can use capital AZ. So if I change this, boom, 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 there's boom, 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 and then just let's raise that. So this will test to see if there's uppercase characters, but it doesn't tell me if there are any lowercase. So this is going to is going to return H, so that's going to be true. And that also returns true. So it doesn't tell me if I've got lowercase characters. So these are both, at the moment, these are both going to pass, which is not what I want. I'm trying to find something that is all capital letters, all characters, and without lowercase. So that's why I'm using the slightly more elaborate, looking for the lowercase things, and if there are there, then make it false. But I'm still getting false positives with this shouting 1, 2, 3. So it's so what I did was have both in there. So I'm checking that there are capital alphabetical characters and checking there are not lowercase alphabetical characters. And then just ANDing these two together, and that makes sure that we're actually covering both. So both these statements need to be true, and if they're both true, then it's true, and if one of them or both of them are false, then it's false. So if we evaluate shouting, oops, fingers and thumbs today, then we don't get the false positive of 1, 2, 3 anymore, but we do get hello 1, 2, 3 as passing. So that was one that caught me out quite a few times as well. But a combination of these refines is working okay. And then we've got a yelling question. So we've kind of done question and yelling now, so we could actually just combine them together. So this part was the question part. And this part was the yelling part. So again, if they're both true, then we're yelling and also asking a question at the same time. So that was fairly simple. Yep, so that's true and that's false, because this has got lowercase characters as well as uppercase. Yeah. So as long as you get the yelling and question individually correct, then this one's just a matter of ANDing them together. Then Bob saying nothing. This was a bit fiddly as well at first. So I tried different things. I think if we did a search for "find by the way," I think it's more of the false positives that were tripping me up. So we're just using Helm Swoop to search through these, so I can basically skip through these different search results. So you can see that it's either going to be a space, either going to be an empty string, a white space, or like this, that's like tabs, I think, and then there's a new line, a return, and a tab in there as well. So there's basically special commands or special characters that we want to pick out. So again, this is not really, there are some tests that are just meaningless, but this is a specific kind of meaningless, not actually saying any words. There's no characters in these tests. So we've got an empty string, white space, or not an alphabetical character. So we can use a regular expression of alphabetic characters to filter out string, and if there's any left as well. So what do we do? So does the string contain special characters? We could do that. So that's, we're doing here a reseek, which is going to generate a new sequence from there, and so that's producing a new sequence. But if we do that on, oh yeah, and then we're counting the characters, I think. Oops, is that working? Using character. Oh yeah. So here, if we're using A to Z and A to Z, this is going to pick out each individual character. And they're all going to pass, so they're all put into the new sequence that we generate. If we do it with this little hat sign, it basically says anything that's not a sequence. So we can see that hello does contain characters from A to Z. So as we invert that, it's going to produce an empty sequence, nil. And so we can use A to Z. So if we use this basically not A to Z on a bunch of tabs, then it's going to return true because there's nothing A to Z in here. So that would work, and then we could just count, and if that number is greater than 0, then it's true. That's a very simplistic way of doing it. Ideally, rather than using testing something's bigger than a particular number, here I'm just seeing if there's something in the sequence. So you can just use seek for that. It's basically saying if there's something returned from this reseek, it's a sequence. It's not nil. It's returning a sequence, so that's true. Whereas if this was hello, then it would be false because seek would detect that there wasn't a sequence returned. There we go. Oops. Yeah. And then for white space, there is blank. So Clojure.string blank will pick out a white space, and yeah, so that's pretty straightforward. But if there's characters in there, then it's going to return false as well. So we just combine those together, and that's all kind of working quite nicely. Although that's also getting picked up because we've got these dashes in here as well. So this was causing a false positive. What did I do? Oh yes, so instead of doing this reseek with like A to Z, I think I was looking for this /t inside a regular expression when it's in the quotes. It's not just going to look for t, it's going to look for all of the matches in there. So if you go back to the website, there's this regular expressions cheat sheet, and like if you go and search down here for -t, wherever it was, I think I might have gone past it actually. Where is it? Yeah. So we can do those, so you kind of do that there. Oh, okay, right, yeah, and then, yeah, so we can match, so it wasn't t, so /t is for the tab, but /s is for like the collective versions. That's what I was looking for, wasn't it? Yes. Yeah, so here, this is going to match a single whitespace character and also tabs, form feeds, line feeds, and other Unicode spaces. So this is a nice kind of character class that it's picking out. So we can use this to represent all the things that are kind of garbage in here. So if we just use this rematches, so this is going to search for individual character that represents either a tab or a new line or a white space, and it's going to do it multiple times, however many times it needs to, so there can be multiple instances of that. So that's coming up with a value, so that's going to be true. And if we do this with this should be false, so that's returning nil, so that's going to be false. This is returning a value, so this is going to be true. So we're going to have a look at some more regular expressions like this when we refactor the solution. And then whatever else, hopefully, is just whatever we haven't captured. So we can, that should be fairly, that should just happen by default. It didn't quite work out that way, but I got pretty close. And then we want to put all these together. So what I did was, just for clarity initially, was just to use the defen that we need, that comes with the challenge. So you need the response for function, because that's called by the tests, and it takes in a string, what I call a phrase. And so we've got three let bindings. So question is this the question is this thing to just check that there's a question mark at the end. Then we've got the yelling patterns that we've used there, and the say nothing. So I've used here, I kind of used the fact that if it's got a T in there, then it will match, because all of the tests had a T in there that failed. So it's either blank or it's got a special character in there. So you can either use this reseek, or you could use the rematching /s. And because now we've got our rules, as it were, then we can just have a cons statement that just puts them together. So we've got yelling question, because we want both yelling and question to get this response, and then question and yelling. I did change these around a little bit to make the test work, but that's easy enough just to kind of move these into the right order. But this seems to be the order that works the best. If I do that, there we go. So using the response for, it kind of passes all the tests. So that's a fairly nice kind of use of the kind of regular expressions, and using refind to see if it can find any particular character sets in a phrase. And same for reseek. So reseek is just taking the phrase and creating individual characters from it, and then we can see whether it's actually created a new sequence to see if there are particular characters in there, and then we can just wire them together with cond. You could put these patterns directly in here, but then you'd have a little bit of repetition because you're using question twice. So you'd have that bit of code in twice. But yeah, it does kind of make it simpler, I think, to read, a bit cleaner to read. And I've just put spaces in between these as well, so you can see if you've got this expression to be true, then you'll return this string. And same for that. So if question is true, then you return string, and so on and so on. And so this will hit on whichever true value it finds first. So whichever of these are true, then it'll return its associated string. Otherwise, it'll return whatever. It normally would use else, but you can actually use whatever keyword you want in there, and not just whatever. You can use a legal keyword in there if you want to, just to be a bit more expressive. Although CLJ Condo suggests I should use else. I'm not sure if I agree with them on that, but there we go. So that's a working copy, but I did a slightly different version of that. There's no questions yet, so let's continue. So we saw a little bit of rematches there in that example. So let's look at the rematches in a little bit more detail and some more gnarly looking regular expressions. So we're going to have like a 15-minute crash course on regex. The rematches, if the string matches the pattern, then the string is returned. Otherwise, it's going to return nil. So basically, does this pattern, do all the characters match the regex pattern? If it does, it's just going to return the original string. And if it doesn't, if the string doesn't conform to the pattern, then it's going to return nil. So it's a nice, easy way to kind of have a predicate, a true-false expression. So we've seen that A to Z will match on any character between A and Z inclusive, and if we do the hat, the caret, before that, it's kind of the inverse of that. So it makes sure that it doesn't match A to Z. Star will repeat the preceding pattern any number of times, and A to Z is kind of like any number of that particular pattern, so any number of uppercase characters with the plus. So if we do rematches on hello, this is failing because it's got this is being broken, this part of the pattern is being broken, and this pattern is being broken as well. So we can have, so we can't have lowercase characters either side of the uppercase characters or at all. But if we have all uppercase, then it works. And we're okay if there are numbers and other characters, that's fine. We're still going to be happy with that because we're only looking for those uppercase characters. So I kind of prefer that it's all self-contained in the pattern, and it does simplify the code a little bit, so long as you're comfortable with the regular expression syntax, which is worth learning. Although if you're not using it every day, it's very easy to forget as well. But they can be a lot more powerful than what we did in the previous solution. So, for example, when we're looking to find the is there a question? Is a question? So yes, we can use the character to match on the character, on the question mark character. So here we've got rematches, and we can just express in the string saying that, okay, we're just looking for a question mark. So that matches the question mark, but if there's anything else in here, blah, then it's failing. So it's only looking for a single character here. If we do the dot, then it matches any single character, so we can put in R in front of it. But if we put anything else in here as well, then it's failing because this is more than a single character in front of it. But we can repeat the single character by using the star, and then any number of single characters followed by a question mark, which is good. Because if we have this one where we do that, I think that's going to fail because it's got characters afterwards. So there is one test where there's a question mark in the middle of the string. So this makes sure that we're only picking up the occurrences of it happening at the end. That's what we're working towards. So to that effect, we use the dollar, which is a so-called boundary assertion. So it makes sure that it's defining where we should match the pattern at the end. So if there's a question mark at the end, that's fine. But if we move the question mark in the middle, then that's nil. So the dollar just makes sure that we're not kind of matching the question mark in the wrong place. There we go. And then there's the other case where what if there's like white space after there or characters after there. So this is specifically saying if there's white space. So we've seen the /s set denoting white space or other space type characters like tab. If there's that, if one occurs after that, then we'd use the /s. If we want multiple spaces, then we're doing the star after the /s. So let's just show that as well. So if we didn't have the star, then that's failing, but with the star, that's passing. So we can pass. If we only have one space there, then that's okay. But with multiple spaces, then that's failing. It did take a bit of working out, but it's very, very useful, very, very powerful. And then once you know them, then you can just use them over and over again. So when we want to match white space, then obviously the /s is going to match both like the empty string, which is handy, and a string with white space. So that covers all the kind of bases that we have for that particular, saying nothing in there. Because this is also going to match for the if there are oops, I didn't want to do that. So this is also taking care of the tabs and new lines and so on. So we're still using a cons, but what we're doing now is just kind of streamlined the code an awful lot more. So we've got question here. So using this has to be a question mark. It can have any number of single characters beforehand, and it can have white space or tab characters afterwards, and the question mark needs to be at the end. So that deals with all the cases for question, yelling, uppercase but no lowercase, and for the silence, for not saying anything, then it's going to be spaces or tab characters. And so then we can just put them in order, and that works. So if we go to Bob, that is the solution I've decided to use. So that's what I submitted to Exorcism. So if we evaluate this, run all my tests. Whee! Yay! They're all running. It's always nice to have green results in tests. And that's it. So it's a fairly simple solution at the end, but you do need to know your regular expression patterns, or you need to go onto like a site like the Mozilla regular expression syntax cheat sheet that I used. Without this, I wouldn't have been able to do that so nicely. So this is really useful. And there's lots of other kind of very useful character classes to look at, and assertions you can make as well. So it's worth having a look at the cheat sheet. This is kind of one of the nicer ones I found. it just explains an awful lot of things there. Yep. Any questions on that? Hopefully you weren't too scared off with the regular expressions. It can seem a bit daunting at first. You think, well, what is that? But the way I tackle that was to basically just break it down and just use the simplest possible things and start building it up from scratch. It's a good way to kind of understand somebody else's complex things. You do need to know a little bit of the structure, so you do need to know about dot and star, what they mean, and character is fairly easy because it's the same as the character in Clojure, and S is a special case of group of characters, and dollar is a setting the boundary conditions for the pattern as well. So it's not too, hopefully it's not too difficult to follow, and is, you can see the code here is a lot simpler in terms of size. It feels a lot cleaner in this way. What else? Was there anything else? No, I think that's it. I don't think of anything else to cover today. We're going to mention anything in here? Nope. So this regular expression cheat sheet is in the chat as well. That's it. Oh yeah. So I posted my solution to Bob for Bob to exorcism. You can just do a exorcism upload and then the path, and then you can decide whether you can get some mentor feedback, or you can just continue on doing a lot more projects in the Clojure track. So I've got a lot more to do. So nucleotide and Hamming are fairly easy. As I found the RNA transcript quite easy as well. TUFA is really easy. Hello World's easy. And then it just depends how well you actually understand the questions for the rest of them, really. And I also do mentoring as well, so I do mentor on the dashboard. So if you do submit some questions, then I get notification that there's 12 solutions now. That was only 8 earlier on. I've got a 5 out of 5 rating. Whoa, nice. So I go in and go and give feedback on other people's solutions that they submitted as well. You don't have to do this, you can just pile on for yourself, but if you want to, you can always send in a solution and get some feedback on there as well. It does help. Mentors can also kind of pick out idioms that you can use that you may have missed, so it's very useful in that respect. Okay, I'm going to leave it there. Oh, it was a question, that was quick. I don't understand why use dollar with rematches. Doesn't rematches always match the whole string? Yes, so let's have a look at the dollar again. That's the wrong bit of screen to click on. There we go. So let's look at the dollar. That's what I was using. I was using the dollar here. So if I, so if I'm in this one, I'm looking for the question mark character, and it can be after any number of characters. But it should be in the last position. So the dollar here is saying it should be in the last position, because here it's is that gonna yeah, because if I don't do that, then it's it's still working. Okay, maybe I don't need that then. That's a good point. This is why I like the replica, because you can just go in and change things, check things. So maybe we can drop the, if we're using that with rematches, we can drop that. I think I was probably using it with refined, where you probably do need it, I think. Although sometimes it's good to be explicitly including things as well. So I think it seems to be working with or without that. So that's a good point. Doing that bit, yeah. So is that still going to work? Oops, what did I do? Oops, press the wrong button. Boom. Where's he gone? There it is. Okay, so that's still matching. Yeah, that's fine. That doesn't make any difference on there. I don't actually need that. Okay, but it was useful. I thought it was important to include it, but I didn't realize rematches also caught that if I don't use it there. So I'm doing that. Nil. Okay, yeah. So rematches is ensuring that this is kind of at the end of the word. Oh, thank you for pointing that out. Alrighty, I'm going to leave it there. I'm going to update my solution, and all these codes on GitHub, as I mentioned before. And feel free to go and hack it in there, and you can. I'll push up the deps.edn file as well, so you can use that. Cool. Alright, well, thank you very much for listening, and if you've got any comments or suggestions, feedback, let me know via the channels that are on the Practicalli website, and we shall see you next time. Thanks again. Bye-bye.